In modern warfare, air superiority is not defined only by advanced fighter jets or cutting-edge missiles. The true power behind every high-performance aircraft lies deep inside its engine, a system so complex that only a handful of nations in the world have mastered it. Today, Turkey is attempting to join that elite group by developing its own domestically produced fighter jet engine, a move that could reshape the balance of power in global aerospace.
Dark notice. The unseen exposed.
Over the past decade, Turkey has rapidly expanded its defense capabilities. From combat drones to naval warships and next-generation fighter jet programs, the country has demonstrated a clear ambition to reduce reliance on foreign technology. However, among all these advancements, building a modern jet engine remains one of the most challenging and strategic goals. A fighter jet engine is not simply a mechanical device. It is the result of decades of research in aerodynamics, material science, and digital engineering. The process begins long before any physical component is manufactured. Engineers rely on advanced simulations and high-performance computing systems to design thousands of individual parts, each optimized for extreme conditions. Artificial intelligence is increasingly used to refine these designs, ensuring maximum efficiency and durability. But what makes this challenge even more difficult is the environment inside a jet engine. Temperatures within the combustion chamber can exceed the melting point of conventional metals. To survive these conditions, engineers use specialized materials such as titanium alloys, nickel-based superalloys, and single-crystal turbine blades. These components are engineered with microscopic precision, often including internal cooling channels that allow air to flow through the blades, preventing them from overheating.
At the same time, modern engines rely heavily on digital systems. One of the most critical technologies is Full Authority Digital Engine Control, or FADEC. This system continuously monitors and adjusts fuel flow, air pressure, and thrust output, allowing the engine to perform optimally under different flight conditions without direct pilot intervention. Inside a modern production facility, the level of precision is extraordinary. Automated assembly lines operate with industrial robots capable of performing complex tasks around the clock. From precision welding to laser-based inspection, every stage of production is monitored to ensure zero tolerance for error. Even the slightest imperfection can lead to performance issues at supersonic speeds. Before any engine is cleared for operational use, it must pass a series of extreme tests. These tests simulate real-world combat scenarios, including rapid acceleration, high-altitude conditions, and intense temperature variations. Engines are pushed to their limits, running at maximum power to verify structural integrity and reliability. At this point, an important question arises. Can Turkey successfully overcome the technological and financial barriers required to build a world-class fighter jet engine? And if it does, how might this shift the global defense landscape? Share your thoughts in the comments below. One of the key objectives of this program is to achieve what is known as supercruise capability. This allows a fighter jet to maintain supersonic speeds without relying on afterburners, significantly improving fuel efficiency and operational range. Until now, this level of performance has been limited to only a few advanced air forces. For Turkey, the implications go far beyond engineering success. Developing a domestic jet engine represents strategic independence. It reduces vulnerability to export restrictions and foreign political pressure, allowing the country to fully control its defense production pipeline. In recent years, Turkey has already increased its defense exports, and a locally produced jet engine could further strengthen its position in the global arms market.
Equally important is the long-term impact on human capital. Universities and research institutions across the country are now focusing on aerospace engineering, nurturing a new generation of specialists capable of competing on a global scale. This investment in knowledge and innovation is essential for sustaining future advancements. Despite these efforts, the reality remains that only a small number of countries have successfully developed their own fighter jet engines. The complexity, cost, and technical expertise required create a barrier that is difficult to overcome. However, Turkey's continued progress suggests a determined effort to break through these limitations. As the global defense industry evolves, the ability to produce advanced propulsion systems will remain a defining factor of military power. Turkey's pursuit of a domestically built fighter jet engine is not just about technology, it is about positioning itself as a major player in the aerospace sector. The coming years will determine whether this ambitious project achieves its full potential. If successful, it could mark a turning point, not only for Turkey's military capabilities, but also for its role in shaping the future of modern air combat.